Assalamualaikum and hi everyone. This video is to help you to understand more about the nucleophile, electrophile and types of reactions. Let's start. As we know that nucleophile means nucleus loving. When it is a nucleus loving means it will be attracted to something that is positively charged. So when it is attracted to positively charged indicates that will be the species that have the negatively charged, or as a definition, it is an electron-rich species that can donate a pair of electrons to form a bond. Electron-rich is something or some species that is rich of electron and will be attracted to the nucleus, so it is nucleophile. So this is example of nucleophile: anions, species with negative charge, carbon ions, carbon with negative charge from the heterolytic cleavage, and molecules with lone pair such as ammonia, H2O. It can also act as nucleophile. Okay, electrophiles, literally electrophiles mean electron loving. When it is as electron loving, it must be something that is positively charged because it will be attracted to something that is negatively charged. As a definition, it is electron deficient species or electron poor. Species that is poor of electron, which accept an electron pair from a nucleophile. This is example of electrophile, such as Lewis acids, which act as electron pair acceptors such as AlCl3, FeCl3, BF3. If you still remember, all of these species have empty orbital because it involved in the incomplete octet, so it is readily accept electron pair. Cations, also with empty orbital, carbocations. Okay, so all of these species are electron poor. Oxidizing agents such as Cl2Br2 and also polar molecules such as HCl and HBr. Okay, let's go to the types of reaction. We have four main types of reaction, which is substitution, rearrangement, elimination, and addition. But for substitution, we have types of reaction, which is free radical substitution, nucleophilic substitution, and also electrophilic aromatic substitution. Same goes to addition. We have two types of reaction, electrophilic addition and also nucleophilic addition. Okay, let's learn about how to identify type of reaction in our chemical reaction. Two fundamental concepts, which is functional groups create reactive sites. So electron-rich site react with electron-poor site. Or in other words, nucleophilic or electron-rich site will react with electrophile, while electrophilic, which is electron-poor site, will react with nucleophile. So it will always be a pair of nucleophile and electrophile in a chemical reaction. For example, in this reaction, we look at the product here. The reaction is occur at this carbon, as initially this carbon consists of hydrogen atom, but after it react with bromine compound with the presence of UV, this H has been substituted with bromine atom, indicates that this is a substitution reaction. But how to determine which type of substitution? We will look at the reaction site. So the site of reaction is at this carbon, which this carbon is located at this benzene ring. We know that benzene ring compound with multiple bond, which is double bond, single bond, or benzene ring, is known as electron-rich site. So when it is an electron-rich site, it is a species that love nucleus, so it is nucleophile. When it acts as nucleophile, we can say that this compound acts as nucleophilic site. When it is nucleophilic site, the pair of nucleophilic site or nucleophile will be the electrophile. So, how to determine the reaction? The type of reaction is depend on the compound that act with the reaction site. So, as it is a nucleophilic site, electrophile will be attack the nucleophilic site. So, this reaction named as electrophilic aromatic substitution. Philic aromatic substitution. Look at this example. CH3Br plus KOH, it will produce CH3OH. The product OH here indicates that bromine has been substituted with OH. So this is substitution reaction. So as it is substitution, let's identify which type of substitution in this reaction. So as Br is attached to carbon, this bromine atom is attached to carbon, and we know that bromine is more electronegative than carbon, so make it as partially negative and this carbon as partially positive. And the reaction site or the reaction occur at this carbon as this bromine out and OH in. So, this carbon has partially positive, means that this carbon acts as electrophile. Why it is as electrophile? Because it has positive charge and it is an electron deficient and it is an electron loving. So, when as electron loving, it is known as electrophile. As it is an electrophilic site, its pair will be the nucleophile. So, this reaction is named based on the species that attack the site of reaction. So, this what we call as nucleophilic substitution reaction. Okay class, let's try this exercise. Okay, A. First we look at the product form. From the product, we can see that this OH has been substituted with this chlorine. So, this reaction is substitution reaction. But what types of substitution is depend on the site of reaction. The site of reaction is at this carbon, and we know that this carbonyl group C double bond O, when C attached to O is more electronegative than C, make this C as partially positive and this oxygen as partially negative. So as partially positive, this carbon acts as electrophile. So when it is as electrophile, it is as electrophilic site, and the pair of electrophilic site is nucleophile. So this reaction is nucleophilic substitution. For B, first we will look at the CC double bond here. We know that CC double bond is unsaturated compound. When double bond break into single bond, so this reaction is kind of addition reaction. So what kind of addition reaction? We will look at the site of reaction. As we know that CC double bond is an electron-rich site, so it is as nucleophile or nucleophilic site. When it is as nucleophilic site, the pair of nucleophilic site will be the electrophile. So, the type of reaction is depend on the species that attack the reaction site, so it is as electrophilic addition. The third one, same as B, CC double bond has break into single bond, so it is addition reaction. what kind of addition reaction is, it depends on the site of reaction. CC double bond is electron-rich site, so it is as nucleophile or nucleophilic site, and its pair is as electrophile. So this reaction as electrophilic addition. For this reaction, it is we can see that the CC single bond here has become double bond. So when it is from single bond to double bond, it is an elimination reaction. It is not electrophilic, it is an elimination reaction. Okay. Next is CH4. We know that CH4 consists of all single bonds. It is an alkane. An alkane, it is only one reaction that will occur in alkane compound with the presence of UV. So it is as free radical substitution. And lastly, when we have this benzene ring react with HNO3, so this hydrogen has been substituted with NO2. So this is kind of substitution reaction. Types of substitution is depend on the reaction site. This carbon as reaction site, and this carbon is located in benzene ring. So we know that benzene ring is an electron-rich site, so it is as nucleophile or nucleophilic site. When it is as nucleophile, its pair will be as electrophile. So what kind of reaction is depend on the species that attack the electron, the reaction site. So it is electrophilic aromatic substitution. Okay, let's have a look at another example. So this is an alkane with all single bonds. We react with bromine in the presence of UV, so it is a free radical substitution. For this reaction, this all single bond at first become CC double bond, so it is as elimination reaction. This reaction, we can see that this hydrogen, initially it has hydrogen, but this hydrogen has been substituted with this compound. Okay, so when it is substituted with this compound, it is a kind of substitution reaction. What type of substitution reaction depend on the electron? Depend on the reaction site. The reaction site at this carbon, which is located at benzene ring. So we know that benzene ring is an electron-rich species. Electron-rich species is as nucleophilic site. So when it is a nucleophilic site, the pair of nucleophilic site will be the electrophile. So it is an electrophilic aromatic substitution. This reaction involves the rearrangement of the atom in the compound become a new compound. So we call it as rearrangement. For this last example, we can see that the change occur at this site. So at first it has CC double bond, but after it react with this compound, the CC double bond has break. So when from double bond to single bond, it is a kind of addition reaction. What kind of addition depend on the electron, depend on the site of reaction. So this is CC double bond, which is electron-rich site. So electron-rich site, we call it as nucleophilic site. When this is as nucleophilic site, its pair will become the electrophile. So this is electrophilic addition. So hopefully all of you can understand how to determine the type of reaction based on the explanation in this video. If you have any question or any comment, you may ask me or you can ask your lecturer immediately. Thank you, class. Bye.